Okay, everyone, welcome. In today's video, we're going to try to solve problem number 10 from Project Euler. I'm going to copy this in as always. The first thing we're going to do is create a new VI and copy this into here so we can keep referring to it. I'm going to save this as problem number 10 now, finally in double digits. Problem 10, and this is called summation of primes. Okay. All right, now this should be relatively straightforward because we already have an algorithm that will check for prime numbers. So all we need to do is keep an array of all of the prime numbers that are below 2 million and then add them all up. So that should be pretty straightforward. The way that we're going to do that is we're going to put this into a while loop and we're going to plug this into here and we are going to index this number. Tunnel mode, concatenating, and indexing. There we go. And then tunnel mode conditional, and we're going to plug this prime into here. And we are going to do this as long as we're going to end this loop when this becomes greater or equal, because it has to be below 2 million. So this is going to end when this number becomes greater than or equal to 1,999,999. And that is when we're going to stop this loop. And then we're going to add all these array elements together. And this should be summation of primes. Now, normally I would do a lot more debugging, but this is such a simple algorithm. I'm not going to really worry about that and just see if I get the right number. So the last thing I'm going to do is create an indicator here because I don't really know how long this is going to take and I want to be able to kind of see the progress of this in real time. I'm going to do one more thing. This is going to be kind of interesting. So I'm actually going to divide. So I'm going to convert this to a double. I'll explain what I'm doing here while I'm doing it. I'm going to convert this to a double. And I'm going to divide that number again by this number. And then I'm going to create a little progress bar. And I'm going to call this progress. And I am going to hook it up here. I'm going to change this to a double. And I'm going to change the properties in here so that the number or the bar is full when the number equals 1. So what this is actually going to do is it's going to give me a little progress bar. I'm going to look at the current number and I'm going to divide it by the total size of the number that I need to get some number between 0 and 1. And as this number goes up, I'm going to see this progress bar update, and that'll give me sort of an estimate in real time as to where I'm at and how much progress I have made and how much further I need to go. So we're going to run this. See our little progress bar filling up. You can see this is taking a little while and it's taking longer and longer the higher the numbers get, because the higher the number gets, the more computations you have to do to check to see if the number is prime or not. Okay, so if I look at the summation of primes, I'm going to find this number, and it is what? Okay, so the algorithm finally finished. Let's look at this number, and it is 100,000 million, almost 11.8 million. And I go here to problem number 10, and that is not right. It should be a lot bigger. Should be 142 million. So let's see what I've got going on here. First, let's make sure this is 2 million. Okay, it is. Find the sum of all the primes below 2 million. What am I doing wrong here? Let's rerun this algorithm, and I'm going to say 10. I'm going to change this to 10. And we're going to look at this and see, okay, so that is correct. Oh, wait, I think I know what the problem is again. I think it's the same problem we had last time. And And it is the fact that, I don't know, because we're in the millions. I thought it was going to be an overrun issue. 100,000 million. Oh no, 100,000 million. Yeah, it is a problem with that. So my problem is that 2i64. This is not large enough to actually hold the number that I need it to. So we're going to do this representation. And I think that'll actually fix it. So again, I was miscounting. Let's see, I don't know what will happen if you do a summation of a bunch of numbers in an element. I'm not sure where it gets truncated, but it obviously did. So let's run this again. I think this should fix it. I'm gonna add one more thing just to keep this interesting. Let's do an elapsed time, and I think we can do this by get date time in seconds. Yeah, I think this should work. So I'm going to do this. I'm going to put another one on here. I'm going to subtract the final minus the initial. And this should give me, oops, just kidding, 2 timestamp. And I'm going to create an indicator off of this. Create indicator. Elapsed time, and then I'm going to change this, oops, so that it is showing me not it in this funky format, but I'm going to change it so that it's showing me just the time in hours, minutes, seconds. Okay, so I'm just going to make this smaller. I'm going to just ignore this PM here, and we are going to try this again. Oh, need to change this back to 1999999. There we go. And now not only can I see a progress bar, but I can see kind of this nice little elapsed time. So we can see how much time has gone and how long these computations are taking. This is kind of interesting. You can see here, this always happens in LabVIEW because of the way the epochs, or epochs as some people say them, work out. The 0 time is actually always aligned to this like 4 hours. I don't necessarily understand why. I feel like I looked into this once, but we're just gonna ignore this 4 for now, and we can see if we can get that out later. Okay, the algorithm is done. Let's see what we did. I think this looks correct. Okay. So I think it is 142,913,828,922. So that was indeed the problem. We had the, again, I was getting numbers truncated here. Again, I'm not exactly sure how that worked out in the add array elements. It happened in here somewhere. I think it probably wrapped around, and that's why I got kind of a weird number. But this is how we solve problem number 10, summations of prime from Project Euler. Hope you enjoyed. Bye.